Welcome to the Insightful Professor. Today we'll be discussing intrusion detection. A significant problem from a security perspective for network systems is hostile, or at least unwanted, trespass by either users or software. User trespass can take the form of unauthorized logon or other access to a machine. In the case of an authorized user, this could involve the acquisition of privileges or performance of actions beyond those that have been authorized. Software trespass includes a large range of malware variants. In this discussion, we'll be examining the nature of intruders and how they accomplish their attack. Then we'll move on to discussing strategies for detecting such intrusions. The goal of intrusion detection is seemingly simple: detect intrusions. Before we consider intrusion detection in current systems, let's go back a few years and consider how this might have been accomplished. Originally, system administrators performed intrusion detection by sitting in front of a console and monitoring user activities. A vacationing user is logged in locally. This might get the administrator's attention. A seldom used printer is unusually active. Again, something else that might catch the eye of the administrator. This approach was ad hoc and was not scalable. As we move ahead in time, we see that audit logs were reviewed by administrators looking for evidence of unusual or malicious activity. And during the 1970s and 1980s, printed audit logs were done in such a way that they were printed on fan-folded paper, often 4 to 5 feet high for an average week, making the approach quite time-consuming. Due to the volume of information and a limited manual approach to analysis, logs were used as a forensic tool to determine the cause of some security incident well after the fact, with little hope of catching an attack in progress. Progress was made toward the use of online audit logs, but still most intrusions were detected after they occurred. In the early 1990s, real-time intrusion detection systems reviewed audit data as it was produced. This enabled the detection of attacks and attempted attacks as they occurred, allowing for real-time response and attack preemption. In reality, the task of intrusion detection is quite difficult. Intrusion detection systems do not actually detect intrusions. They only identify evidence of intrusions, what we'll call an attack manifestation. The system cannot detect intrusions if there is no manifestation. The manifestation lacks sufficient information, or the information contained in a manifestation is untrustworthy. Let's look at a little example outside of computers. Consider a house monitoring system that is analyzing camera data, which shows a person fiddling with the front door. The camera video is the manifestation of the occurring intrusion. If the camera lens is dirty or out of focus, the system will be unable to determine whether the person is a burglar or the owner. A key threat to security is the use of some form of hacking or exploitation of a system weakness or vulnerability by an intruder. This intruder is often referred to as a hacker or a cracker. We'll consider the following broad classes of intruders in our discussion: cyber criminals, activists, state-sponsored organizations, and then something other than one of these three. As with any defense strategy, an understanding of possible motivations of the attackers can assist in designing a suitable defense strategy. Keep in mind that across these classes of intruders, there's also a wide range of skill levels. Let's first consider cyber criminals. These are individuals or members of an organized crime group with a goal of financial reward. Their activities may include identity theft, theft of financial credentials, corporate espionage, data theft, data ransoming. Typically, these folks are young, often Eastern European, Russian, or Southeast Asian hackers who do business on the web. They tend to meet in underground forums to trade tips and data and coordinate their attacks. The next category is activists. These are either individuals, usually working as insiders, or members of a larger group of outsider attackers who are motivated by social or political causes. They're also known as hacktivists. Their skill level is often quite low. The aim of their attack is often to promote or publicize their cause, typically through website defacement, denial of service attacks, theft and distribution of data that results in negative publicity or compromise of their targets. Well-known recent examples include the activities of the groups Anonymous and Lulsec, and the actions of Chelsea Manning and Edward Snowden. State-sponsored organizations are groups of hackers sponsored by governments to conduct espionage or sabotage activities. These activities are also known as Advanced Persistent Threats, or APTs, due to the covert nature and persistence over extended periods involved with any attacks in this class. Recent reports and information revealed by Edward Snowden indicate the widespread nature and scope of these activities by a wide range of countries, from China to the USA, the United Kingdom, and their intelligence allies. An additional category extends beyond these three primary groups. We simply refer to it here as others. These are hackers with motivations other than those previously listed. And this could include hackers or crackers who are motivated by technical challenge or by peer group esteem and reputation. Many of those responsible for discovering new categories of buffer overflow vulnerabilities could be regarded as members of this class. Given the wide availability of attack toolkits, there is a pool of hobby hackers using them to explore system and network security. Earlier, we had indicated that among the classes of intruders, there's also a range of skill levels. So let's consider these skill levels. First, apprentice. Hackers with minimal technical skill, who primarily use existing attack toolkits, fall into this level. They likely comprise the largest number of attackers, including many criminal and activist attackers. Given their use of existing known tools, these attackers become the easiest to defend against. Sometimes they're referred to as script kiddies due to their use of existing scripts. At the next level, we talk about journeymen. These are hackers with sufficient technical skills such that they can modify or extend attack toolkits to use newly discovered or purchased vulnerabilities. They may also be able to locate new vulnerabilities to exploit that are similar to some already known. Hackers with such skill are likely found in all intruder classes. They adapt the tools for use by others. The changes in attack tools make identifying and defending against such attacks more difficult. Finally, master skill level. Hackers with high-level technical skills who are capable of discovering brand new categories of vulnerabilities would be classified as having a master skill level. These folks write new powerful attack toolkits. Some of the better-known classical hackers fall into this level. Some of these folks are employed by state-sponsored organizations. Thus, defending against these attacks would be of the highest difficulty. Intruder attacks range from the benign to the serious. At the benign end of the scale are people who simply wish to explore internets and see what's out there. At the serious end are individuals or groups that attempt to read privileged data, perform unauthorized modifications of data, or disrupt systems. Here we list examples of intrusion identified by the NIST. Intrusion detection systems, or IDSs, and intrusion prevention systems, IPSs, are designed to aid countering these types of threats. They can be reasonably effective against known, less sophisticated attacks, such as those by activist groups or large-scale email scams. They are likely less effective against the more sophisticated, targeted attacks by some criminal or state-sponsored intruders, since these attackers are more likely to use new zero-day exploits and to better obscure their activities on the targeted system. Hence, they need to be part of a defense-in-depth strategy that may also include encryption of sensitive information, detailed audit trails, strong authentication and authorization controls, and active management of operating system and application security. Intrusion detection systems and intrusion prevention systems are intended to assist in countering the types of threats that we've described. However, we cannot turn to these systems as a panacea. These systems are reasonably effective against known, less sophisticated attacks, activist groups, or large-scale email scams. However, they're less effective against more sophisticated, targeted attacks, such as those involving criminal or state-sponsored intruders. The attacks are more likely to use zero-day exploits and, of course, better obscure the activities of the attacker on the system. So, as we've stated a moment ago, such systems need to be part of a defense-in-depth strategy. Intruders typically use steps from a common attack methodology. We've identified those steps here, and we'll examine these in detail. The techniques and behavior patterns of intruders shift to exploit newly discovered weaknesses and to avoid detection and countermeasures. A typical sequence of actions might start with a phishing attack. This results in installation of malware that then steals login credentials and eventually results in a compromised system. With target acquisition and information gathering, the attacker identifies and characterizes target systems using publicly available information, both of a technical and non-technical nature. The identity of target resources is determined by using network exploration tools. The initial access to a target system is often achieved through the exploitation of a remote network vulnerability by guessing weak or authenticated credentials used in a remote service, or via the installation of malware on the system using some form of social engineering or drive-by download attack. With respect to privilege escalation, these are actions taken on the system to increase the privileges available to the attacker to enable their desired goals on the target system. Information gathering and system exploit refers to the actions by the attacker to access or modify information or resources on the system, or to navigate to another target system. To sustain the attack, actions are necessary that enable the continued access by the attacker after the initial attack. Such actions might include the installation of backdoors or other malicious software. In terms of covering tracks, the attacker disables or edits log files, audit logs, to remove evidence of attack activity and use rootkits and other measures to hide covertly installed files or code. Let's examine the steps of an intruder's common attack methodology in more detail. First, let's take a look at target acquisition and information gathering. We've indicated some examples of the activities associated with this step. The attacker might begin by exploring the corporate website for information on the corporate structure, personnel, key systems, as well as details of specific web server and operating systems in use. The attacker can gather information on the target network using DNS lookup tools. They could query the Whois database. When a domain name is registered, data will be registered in the Whois database. This database is a publicly accessible database that contains details of the owner and contact person. It also identifies name server data. The attacker could map the network for accessible services using tools such as Nmap. Nmap is a popular port scanner in the hacking and security community. Nmap supports different types of scans, such as ping scan, connect scan, SYN scan, and fin scan. Each of these scans provokes a different response on the target system, and thereby provides different information to the port scanner. The attacker could also send an email query to the customer service contact, and then review the response for information on the mail client, server, and the operating system in use. Additionally, there would be details of the person responding to the email. The attacker could also identify potentially vulnerable services. Moving to the initial access step. There might be a brute force, effectively a guess, of a user's web content management system or CMS password. A content management system or CMS is a software application or set of related programs that are used to create and manage digital content. A web content management system provides website authoring, collaboration, and administration tools that help users with little knowledge of web programming languages or markup languages create and manage website content. The main purpose of a content management system relating to the web is to provide the capability for multiple users with different permission levels to manage a website or a section of the content. So the attacker could exploit vulnerabilities in the web content management system plugin to gain system access, could send spear phishing email with a link to the web browser exploit to key people. Next, we consider privilege escalation. In this step, the attacker can scan the system for applications with local exploit. They could exploit vulnerable applications to gain elevated privileges, install sniffers to capture administrator passwords and use captured administrator passwords to access privileged information. In the information gathering and system exploit step, the attacker could scan files for desired information, transfer large numbers of documents to an external repository, use guessed or captured passwords to access other servers on the network. To sustain access to the system, the attacker could install a remote administration tool or rootkit with a backdoor for later access. The administrator password could be used to later access the network. And the attacker could also modify or disable antivirus or IDS programs running on the system. And finally, to cover their tracks, the attackers could use a rootkit to hide files installed on the system. And they could also edit log files to remove entries that were generated during the intrusion. On this slide, we provide some definitions found in the Internet Security Glossary from the IETF. Security intrusion is defined as a security event or a combination of multiple security events that constitutes a security incident in which an intruder gains or attempts to gain access to a system or system resource without having authorization to do so. Thus, security intrusion refers to an unauthorized act of bypassing the security mechanisms of a system. Our second definition to consider is intrusion detection. This is defined as a security service that monitors and analyzes system events for the purpose of finding and providing real-time or near real-time warning of attempts to access system resources in an unauthorized manner. Thus, intrusion detection refers to a hardware or software function that gathers and analyzes information from various sources within a computer or a network to identify possible security intrusions. And that's all we'll cover in this first video. So in this video on intrusion detection, we laid the foundation for describing intrusion detection systems. We discussed intruders and intruder behavior. In doing so, we identified classes of intruders and described their skill levels. We also looked at basic principles and requirements of intrusion detection. We discussed examples of intrusion identified by the IETF. We also explained the steps of an intruder's attack methodology. In our next video on intrusion detection, we will describe approaches to analysis of intrusions, such as anomaly detection and misuse, or signature or heuristic detection. We'll also discuss host-based intrusion detection and network-based intrusion detection. And we'll wrap it up with a brief discussion of an available intrusion detection system.